Okay, let's get finding out answers to those questions you've tried. So we're using our GDC in this example. We're making sure we use this domain. And I'm going to put sine x into my calculator and 0.5. I'm making sure, because my domain, if we look at it, is in terms of pi, that means the angle we're talking about is radians. So I'm going to hit the top right of my calculator. I'm going to make sure that I choose the one that's an angle symbol and then a pi to make sure that my calculator is thinking in radians. Then I'm going to plot this. And my first step now is going to be to draw my a little sketch of my graph. So I would like to do something like this for my sine curve, and we're looking at a half, which is roughly there. And looking in this domain, you can see there are two intersections. So I'm just going to use the function intersection of my calculator to get 0.524. And my second point, function intersection, is 2.62. Obviously, check that you're in radians mode. Check that your domain's right. If you want to, if you're struggling with the domain, you can always do shift plot, and you can actually type in your x values as you can type in negative pi and 2 times pi, and then your calculator is going to do a pretty good job for you. Okay, next up, we want cos x, we want negative 0.2. I want to do a little sketch of this one. So my cos curve starts up there. Okay, and I'm doing negative 0.2. Oh, I think I'm going to have 3 answers this time. I can see 1, 2, 3. So, same process as before, function intersection. I'm going to start on the left and work right with these basically. So negative 1.77. Then we've got 1.77, positive 1.77, because it's symmetrical. And then our last one is 4.51. Okay, those are the 3 answers in this domain. Moving on then, question 3, use the triangle shown to find an exact expression for sine 45 degrees. So we've got a triangle, a right angle triangle with a 45 degree angle. If I'm after the sine of that, I'm going to think about the opposite over the hypotenuse. Oh, hang on, what's the length of the hypotenuse? I guess I've got to do Pythagoras' theorem to find that. Let's call it h for hypotenuse. So it would be 1 squared plus 1 squared equals h squared. Now, we're talking about exact solutions. I don't want to get a decimal, so I'm going to keep it in terms of square roots. 1 squared plus 1 squared is 2. And if I'm going to square root that, I will get the square root of 2. Okay, so sine 45 then, the opposite divided by the hypotenuse would be 1 over square root of 2. For being very good students, we will rationalise our denominator, won't we? So that's timesing the top and the bottom by root 2, which gives us root 2 over 2. Okay, moving on. Cos 45 degrees. Well, cos 45 degrees is the adjacent over the hypotenuse, but hopefully you're seeing that the adjacent and the opposite are equal, so it's going to be the same result. So the sine of 45 and the cos of 45 degrees are equal. Hence, write down the exact values of the following. Okay, we've got a few more to think about. Sine negative 45 degrees. Now, how does sine positive 45 degrees and sine negative 45 degrees relate to each other? Let's take a quick look. This is my sine curve. It looks like this. Okay, 45 degrees is this one, and we said it was root 2 over 2. This sine curve has rotational symmetry about the origin. So when I go back 45 degrees here, I know that I'm going to be at negative root 2 over 2. What I've actually done is I've done this, but I haven't really used that formula. I've just thought about it a bit, and I've thought about the function, because I'm not very good at remembering all these formulas. These last two down here are not in your formula guide, and I don't want to fill my head with formulas that I don't need. I'd much rather know what my function looks like, or draw the function, draw a sine curve on my function and figure it out with maths that I don't need to learn. I don't need to learn about symmetry. So sine negative 45 degrees is negative root 2 over 2. If you are someone that does learn formulae really easily, you just do it for fun, then you can do that as a method. That will work fine for you. For the rest of us, we need to find a way that we don't have to worry about remembering so much. Okay, we're going to move on. Cos negative pi by 4. Now, everything up until this point has been in terms of degrees, so I need to think about what is this in terms of degrees. What's pi by 4 in terms of degrees? Well, pi is 180, pi by 2 is 90, pi by 4 is 45. And of course it was going to be 45. Look at all the other angles, they're all 45. So I'm thinking negative 45 degrees. Well, let's do that little trick again. Let's draw a little cosine curve. Good practice for remembering what they look like. Here's 90, I'm looking at 45. Okay, this one has symmetry, but it's not rotational symmetry, is it? This one has line symmetry down that y-axis, and you can see that those values are going to be the same. They're both going to be root 2 over 2. Okay, hopefully these examples have gone okay for you. You should be able to get going on the homework during our lesson, so hopefully you can get a lot of that done, because I'm sure most of you have some work to do on your IAs and you'd much rather be focusing on that at the moment. Okay, I will hopefully see you in our class on Friday. So I'll see you tomorrow. We're going to start looking at day 7, which is taking those curves, sine and cosine curves, and understanding a bit more about transforming them. Okay, bye-bye. Good luck with your work. See you tomorrow.